Good day everyone, my name is Pauline Dumanlang from BSIT2. Today I will explain my solution to a certain problem which is all about encapsulation. So the problem is I have to create a system called CSU Library Borrowing Account where students can borrow books, return them, and pay penalties. However, the important rules is that student must not be allowed to directly change their borrowed book count or penalty balance. All of these changes must go through controlled methods. This means I need to apply encapsulation, which is one of the core concepts of object-oriented programming. Encapsulation means hiding the internal data of a class and controlling access to it using methods. To solve this problem, first is I created a class called Library Account. Inside this constructor, I declared two public attributes, student name and student ID. These are public because they simply identify the student and do not need protection. Then, here is I declared two private attributes, borrowed count and penalty balance. I used double underscore here to make them private. This prevents other part of the program from directly modifying these values. Next is this property decorator. This creates read-only access for borrowed account and penalty balance. This allows user to see current values, but they cannot change it directly. And after that, I implemented the required methods. The first method is this borrowed book. This method increases the borrowed count by 1. However, before increasing it, it checks if the student already borrowed 3 books. If the limit is reached, the system will deny the request. It will print the borrow this line. So the next method is the second method, is return book. This method decreases the borrowed count by 1 if the student has books to return. If the books is returned late, the penalty is calculated by multiplying the number of late days by 10. The computed penalty is then added to the penalty balance. This third method is pay penalty. This method validates the payment if the amount is less than or equal to 0. The system rejects it. It also ensures that the penalty balance does not go below 0 after deduction. Lastly, I created the show status, which displays the student's name, ID, and the number of borrowed books, and the remaining penalty balance. In my test scenario, if we run this code, we'll show the result. First is the student successfully borrowed 3 books. Here. When attempting to borrow a 4th book, the system denied it because the limit is 3. Then the student returned 1 book 2 days late, which added a penalty of 10 here. It will divide 10 by 2 because the student returned 2 days late. 1 day is equivalent to 10. Then after paying part of the penalty, the balance is decreased correctly here. 10 minus 10, penalty balance is 10. Then shows the student name, her ID, borrowed books, and the remaining penalty balance. So a short reflection of how encapsulation prevented errors. So encapsulation prevented errors by hiding important data, allowing changes only through controlled methods. Instead of modifying values directly, the system checks rules first before updating anything. This invalid action keeps the data accurate and protects the program from misuse or accidental mistakes. And that's all for this video. Thanks for watching.